of laying down the law. You don't care to listen, you don't care at all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. The first time I trouble, you're gone to the devil, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. And I'm tired of breaking down the wall. You just keep your distance, and you don't care to call, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. First time I trouble, you're gone in the double, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Come on, boy! And I'm tired of waiting for the fall, and you make no commitments, you can't have it all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me what you need, yeah. First time I trouble, you're gone from the double, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Take it home, boys! Come on! And I'm tired.
All right, we're down to one. All right, so probably because it's right before spring break here, but today we were going to spend all of our time designing a database because we've been working with this database over here in as the video game database, but we started with that, right? I'd already built that. So what we're going to do now is we're going to build our own database from scratch, design it, and then build it from scratch. And to do that, we're going to design it to support our little financial asset application system, where we had an owner, they had emails, they had accounts, including an annuity account and a savings account. And I'm going to throw in this variation here that we want to support joint accounts, where one person can own several different accounts, and one account can have multiple people on it. For example, you could have a joint account between father and their kids or something like that, or whatever. And one question here that we're going to have to answer later on is, how do we handle inheritance? So to remind ourselves, this is the system that we built here as a UML diagram. We've got an account, and there are two types of accounts, subtypes of accounts here, annuity and savings. And then we've also got a person. Through composition, that this person owns an account. It's the owner in this account over here. And they've got a first name, last name, date of birth, and emails. Right? So we're going to whiteboard this. Right? This is what should be done with all of your design stuff. You're going to whiteboard it by simply, drawing down a sketch, and then crossing things out and moving things around, and doing everything necessary to do this. So I'm going to go ahead and start with the really obvious and simple thing, a person. Right? So clearly we're going to need a person table over here. Let me go ahead and draw that. There we go. and I'll call it person. Note that I did not call it persons or people, right? I'm not going to pluralize it for the same reasons I didn't pluralize anything over here in the Java classes. It's the person class, and there are person instances. And over here it is the person table, and there are person records, but it is not the persons table. Right? Very clearly over here we're going to have a first name and a last name, so those are going to be strings. Right? First name, last name. And in SQL, a string is called a varchar. So remember, varchar is a variable character array. I left a little room up at the top. Why? Let's take a look at our database over here. What is common to every single table here? What's the first thing that we put in there? Right? What is that little thing right there? Well, that thing right there. It's a little tiny, it's a key, right? That's our primary key. All of them are integers. All of them are named after the table followed by ID. And so that's what I'm going to do over here as well. Person ID. And I'll label it as a primary key, an integer. Right? That's actually the first thing that you should do with every table. Later on we'll talk about normal forms. First normal form, second normal form, third normal form. And by doing this, this gives you second normal form for free automatically. It's just something that you should do for every table. Right? I've got a first name and a last name. What about date of birth? Date of birth. What is that? Well, over here in Java, what did I choose to use? A local date, because it's built into the language, right? And I don't have to write my own. Well, there is something built into SQL. It's called, oddly enough, date, right? Exactly, but don't use it. It is not interoperable. It's not very useful. You take it from one database management system to another, and it will break. So what we're going to do is we're going to be proper computer scientists about this, and this is also going to be a varchar of the following form. What about today? Today is March, what, 9th? 2023. Is that how a computer scientist writes their dates? Nope.
It's year, month.
Exactly. We use the proper ISO 8601 standard, and today would be 2023 hyphen 09, because we do have leading zeros, today is the March, 03 because we have leading zeros, and then 09 because today is the 9th.
Exactly. When you forget to do it.
When you forget to do it, then nothing becomes orderable. It's all, and then then you're forced to use some sort of a local date structure in order to get stuff done. All right, so we've got our person table here. We've got a first name, last name, date of birth, and we're going to be doing that as a varchar. What about emails? So we did that over here in Java as a list of strings. So one person can have 2 emails, they can have 3 emails, they can have 0 emails. What kind of a relationship will that be with respect to another table? If I have an email table, email, there we go. One person is going to have I do want it to be like that, there we go. We'll have one person will have many emails. Remember, this is a one-to-many relationship. Sometimes you'll see 1 and M. Sometimes you'll see like a ratio here, 1, colon M, something like that. But the chicken foot here is an indication of many. Right? And then the lack of a chicken foot is going to be the indication of a 1. What's the first thing I do in every single table? ID. It's going to be a primary key, it's an integer, and that's our identity, right? Email ID. Again, that gives us second normal form for free, okay? Well, if it's an email address, then we need the actual address. And an excellent question came up yesterday in one of the other sections. If this is going to be a varchar, how do we enforce that it's actually going to be correct? Could you have an email foo at bar without a .com? No, that's not a valid email. There are attempts at regular expressions to do this. Might be able to do a constraint, but ultimately I don't think so. Just like over here, is there a way that you can force this to become a correct date? Like there's no February 29th, or I guess there is a February 29th, to February 30th, right? Or March 32nd, right? No, it's just a varchar, so you could put in bad information here, okay? There is no way to protect against that, or no easy way of protecting against that by using a varchar. All right, how do we bring these two tables together? I clearly want a one-to-many relationship here. How do we do that over here in these tables? So one game has one publisher, right? Remember that this is a parent-child relationship up here. This is the parent, this is the child, right? You cannot have a child without the parent, otherwise you would have an orphan. And we don't want that in our system because that's bad data. That's missing data, right? So clearly, by putting a foreign key in the child table that refers back to the parent, we'll never be an orphan as long as we have that reference back to the parent. Right? Consequently, we need to put a foreign key where? In the person table or in the email table? Email. Why? What if we did do it over here? What if we did it right here? This person has this email and I jump over to this table. That's a one-to-one relationship. Right? So I'll go ahead and put in a person ID here to indicate that this email record is owned by this particular person over here, identified by their person ID. Okay? I'm labeling this as a foreign key. Why did I call it person ID? This is a foreign key that's going to reference this table and this value in that other table. If you name them the same thing, if you follow a consistent naming convention for everything, then there's no guesswork at all when it goes to actually querying out of the database. If you follow the same naming conventions as your Java objects, then you are following a modern naming convention, and there's a nice clean one-to-one mapping from your POJOs, plain old Java objects, to your database. In fact, if it's such a clean mapping, you can use what's called an ORM, object relational model mapping. That is object relational mapping, and then you don't have to write a single line of SQL to connect it to your Java application. We might look at that later on. All right, that's good for those two tables. Let's go ahead and get started. We won't worry about the accounts, the annuity accounts, savings accounts, and everything else just yet. Let's actually go ahead and start writing some SQL code today. How do I create these two tables? Well, first of all, I'm already using my database, and I've already cleared it out, so we're starting fresh. There are no tables in it at all. Funny enough, you use the command create table, right? Because I want to create a table. I should call it the person table because that's what it's called. That's what my sketch, my ER sketch over here called it. I am following an upper camel casing convention for all tables. Why? Because that's what I follow for plain old Java objects. Right? Create table. You can go with an old school way of doing stuff with underscores everywhere. Person table, right? Or something like that. Again, this is a more modern way of doing it. And you'll see that I violated my own more modern way of doing it over here in the example. I think I did that at one point because I wanted to show how you could update tables to change their name. But it's modify table set name equals something. I forget what it is off the top of my head. Who cares? All right, there's my first table. Opening parenthesis, closing parenthesis, and at the end a semicolon, just like everything else. If you want to, you can go ahead and give this some documentation, right? Table to model a person. There we go. Documentation here is going to be a comment, and a comment is hyphen hyphen space. Right. Questions? I think we're going to require a minimum, but I mean, that kind of documentation is kind of trivial. It's the person table. Of course it models a person, right? Why are you writing that? That's kind of crufty in my opinion, right? Now, if there's some other table that is like availability, what is that? Well, I guess I could look over to the game table and the platform table and see that it's a join table, but that might require some documentation. It's available, it's modeling the fact that a game is available on a particular system. Yeah.
So you still have to do documentation in general.
Yeah, in general, like an author, me.
So you mentioned there's the ability to rename tables. Does that update your queries?
It would break your queries. Yeah,
Right.
yeah. Alter table, and you queried it based on another name. Yeah, all of your queries would now be broken.
Ooh, okay.
Yeah. So get a good design up front. All right, so create table. The first thing I'm going to do is that person ID. It's going to be our primary key integer, not null, ... Let me go ahead and show you what it looks like. Person ID, int, not null, primary key, auto increment. So let me walk you through each one of those keywords. First of all, that's the column name, person ID. I named it after a person. I am using a lower camel casing convention. Why? Because again, I want a nice map back to my POJOs, my plain old Java objects. And if in Java, I'm using a lower camel casing convention for variable names, same thing here. Right? It's an integer. You can write integer. You can write int. You can write integer, all caps. Don't get fancy. Just keep it simple. Int. Right? Those are all aliases of the same thing. This is a 32-bit signed 2's complement integer. Right? Not null. I am not going to allow this column to be null. By default, and this is where my documentation will come in, by default, all column values are nullable. In other words, they can have a null value, right? A missing value. If you find, if your design of your database says that, well, that'll never happen, then put in a rule that that can never happen by saying that it's not null. I'm doing this on a primary key because I want, if it's going to be a primary key, then it needs to be a unique identifier. And if it's null, that's like saying that its identity is missing and it doesn't make any sense. But not only that, if you did have this one null record, no other null record could have null as a primary key. So it's kind of useless anyway. I label it as a primary key. That ensures that the database will never give two keys out to the same record. The database handles that, right? That's its purpose. It is 100% reliable, right? It is 2 words, space. And now the one thing that is not 2 words is auto increment, right? I think that that's because it's a database value somewhere stored in the meta files. But in any case, it's no, it's just a auto underscore increment. I don't know. That's that old school underscore casing convention there. But the auto increment means that the database will take care of key management for you. You insert a new record, and it will give it the next available primary key value. Insert another one, and it'll do that. Just as we saw with the video game database, you can hard code those values if you want to for your test data. That's perfectly fine, but the database will handle it for you in actual production, right? In the actual application. Let it do its job. Okay? What else do we need in our sketch here? First name, last name, date of birth. So, first name, and it's going to be a varchar. Right? And here you do have to specify a length. That is a maximum length. It's a variable character array, so if CHRIS, Chris, it's only going to take 5 bytes to store that. It allows up to 255 bytes here. So if I've got a name, a first name for whatever reason is 256 characters, that last character gets chopped off and thrown away. It's called truncation, right? Just like integer truncation. 255 is very, very common. Nobody's going to have a name that long. You could kick it down to 100 or something like that. But 255 is very common for historical reasons. Why? It's 1 less than 256, giving you a null terminating character. C, right? And 256 is a perfect power of 2, 2 to the 8th, and 8 is a perfect byte. Exactly. And so that's why it's 250, historically it's 255. It made a difference back then, right, in the 70s when they were doing this. So last name, varchar, 255. Now by default, by not saying anything here, what I've said is, but both of these are nullable. I could put in a person record here. It'll generate a person ID, but they won't have a first name or a last name. Is that good data? Is that bad data? I have no idea. At this point, you would go back to the stakeholders, whoever is paying to actually build this system, and you would do what's called requirements elicitation. Elicitation is just a fancy word for gathering, right? You're eliciting them for a response, right? You're gathering data. You're gathering requirements for the system. You'd go back and say, is there any record there now or in the future where that you would not have a last name? No? Okay, I'll go ahead and put in that it can't be null. But even then, you don't take their word for it. Because like 9 times out of 10, whenever we've asked this kind of questions in a real system, what is it? Trust but verify? Okay, we'll take your word for that. And then we go back to their data, and then we see, okay, there are 300 instances in which there's no last name here. What do you want us to do now? Because obviously it was wrong. Is that bad data? Should we just delete that? What's going on there? Right? And then, so trust but verify. For now, we'll just go ahead and put in not null. But maybe they don't have a first name, because there might be some cultures where there's only a family name or something like that. Okay? I'm doing it mostly for a variety of demonstration purposes. All right? Date, yeah, I'll do it. Date of birth. There we go. I'm intentionally misspelling it. Don't worry about that. We're going to come back to it. Varchar. Now, because I wanted that date in a proper ISO 8601 format, that's going to be 4 for the year, 2 hyphens, and another 4 for the month and the day. So that's going to be 10. Right? Because if you're putting anything else in there that is longer than that, that's bad data. Right? There's something going on there. Not only that, but what if you don't have a date of birth? Right? We don't know yet. We're going to open up this account for this customer today. And put their cousin on it, but they don't remember when their cousin was born. Right? All right, we'll go ahead and put in a default value, not null, default of 0000000. That will be our flag value to indicate that the date was never entered initially. On the front end, what we can do is we can pull that out, try to turn that into an actual date, a local date, and if it doesn't work, we'll display an error message to the user saying this needs to be entered at some point, right? And that could be our flag value for a non-specified value. When I insert a person record, I don't have to put in that date of birth. Instead, that default value will take over. If I ever tried to marshal that into a local date, it of course would fail, just like February 30th would fail. Right? What's at the end of each line, by the way? A comma, right? So, can we put it in the Oxford comma? No. That is a syntax error, right? That last comma right there. Just like a C structure, you can do that, right? But here you cannot, okay? All right, that's pretty good. Let's go ahead and create that email table now, right? Let's see. Create table email. What's the very first thing that I should do? Copy pasta that, and email ID. Integer, not null, primary key, auto increment. Right? That's the first thing that you should do in every single table. Right? I don't want to save this. Sorry, there we go. Okay. Comma. What else belongs in the email table? An address ID, the actual address, which is a varchar, and the foreign key that references back to the person table. So let's go ahead and put in address. Varchar 255. If you have an email longer than that, great. Right? The other day I put in, just as a joke, default value of example at example.com. There we go. Would you want to do that? Back in the heady days of the internet, somebody came up with the idea that, you know, there are a lot of tutorials out there that are putting in example.com or example.org or things like that. What if I registered that domain and I captured all that traffic, right? Just like another person had the idea of people send out emails all the time with, and they fake out the sender to be donot-reply.com because it's automatically generated. So what if I registered the domain donot-reply.com and then all these idiots start replying? I get their email, right? And then I can go ahead and put it up on a website and laugh at them. And people have done this before. If you go to example.com, you'll see that it's now been registered and it's safe. In other words, you will not, that it is, that a big giant pact has been agreed on by the internet world that nobody will do anything with example.com. So you can continue to use it in your tutorials. If you go to donotreply.com, I believe if you start clicking on stuff, Firefox will very quickly warn you that you should probably not go any further, right? Because I don't know who owns that. But I'm not going to put in that default. But I am going to say that it's not null. Because if it's null, why did you put in that record to begin with? If you don't have an email, then don't put a record in there. A one-to-many relationship includes a one-to-zero relationship if they don't have any email records, right? Finally, that person ID, integer, not null. The not null here is ensuring that there are no orphans. Right? Over here, I made the publisher ID not null so that there could not be a game record with no valid publisher in it. Right? That's not everything, though. What I need to do now is I need to associate this email table with this person table. The person ID needs to reference the person table and the person ID within the person table. This thing needs to reference this table, and within that table, it's referencing this thing right here. To do that, it's pretty straightforward syntax. Foreign key, right? Person ID, references, person table, and within that, the person ID. There. So I am labeling this table's person ID as a foreign key, and I'm saying that it references the person table, and within that person table, the person ID. Now, imagine if I was using a different or old school naming convention where the tables names and the columns were all the same convention. Right? It'd get pretty confusing pretty quickly. And this is why I'm using this modern convention. Upper camel casing tells you that it is a table. Lower camel casing tells you that it's a column. Right? If you want to follow an old convention, that's fine with me, as long as you are consistent about it. Good luck to you. Right? All right. I am going to actually try to execute this, this script here. I'm going to create the email table and create the person table. It doesn't work. When you try to create the email table first here, it references the person table. Does the person table exist on lines 5 through 10? Not yet. So what does that tell you? Just like C structures. Order matters. Right? Let me go ahead and run it all again now. 2 green check marks. I was able to create both of those tables. If I do that again, is it going to work? You can't create a table that already exists. Red X. Right? So if you're doing this and you want to make a change, for example, I misspelled date of birth intentionally, I need to fix that. Okay? If I try to run this again, it's not going to work. So I need to drop those tables first. Drop table person. Right? Semicolon. Drop table email. Be very, very careful when you do this. When you drop a table, that's it. There is no undo, there is no delete, there is no backup unless you actually made a backup. Right? SQL is way less forgiving than this. Right? Let me go ahead and try it now. Still doesn't work. Drop table person. Cannot delete or update a parent table or row. Let me come over here. Can an orphan exist in this table? No. You have a parent-child relationship. So if I want to delete these 2 tables here, if I want to drop these 2 tables, what do I need to do? I need to make sure that there are no orphans, and I need to delete the children and then delete the parent table. So their order matters yet again. Let me go ahead and superimpose those, and you'll see here that it now works. Delete the, I did it in the opposite of creation. If you create A, create B, create C, and you've got that linear dependency there, you need to delete in the reverse order. Not only that, but you can take this a step further. What if I drop table email twice? Right? It's not going to work. So you can make this conditional. Drop the table, but only if it exists. Drop table if exists. It is bad grammar. It's not my grammar, but code is very rarely correct, right? Grammar or whatever. Create table person, you can do the same thing here and can create it only if it does not already exist. If not exists. Right? If not exists. There we go. And now I can run this entire script over, oops, I don't want to save it. I can run this entire script over and over and over and over again and nothing but green everywhere. Right? Awesome. Okay. So I will make sure that you have this in the notes. But before proceeding, what else should we do? That looks like a pretty good design. Right? What else are you going to need? Test data. So let's create the table, and now let's create some people. Insert into person, person ID, first name, last name, date of birth. There we go. And it's spelled correctly now. Values. And then I'll go ahead and give my, 10 and me. I won't call anybody out over here, but I'm definitely not also going to give my own date of birth, real date of birth. So let's just go with 2020. 0101. There we go. Nope. 3 years old. Yep. There we go. 20. We could go with somebody famous. I don't know.
Joe Schmo.
Okay. Joe Schmo.
That's famous, right?
1973. Or
Is that even a real person?
probably somewhere in the world. 1970 0103. There we go. And just to just to show you that it's possible, I can go ahead and put in, I think, 30 Jane Doe and leave this as nothing. Let's see if we can do that first of all. Can I go ahead and do this? Nope. Column count doesn't match, so I'm going to have to allow this to be null. Nope. I can't do that. Why? Because I defined it as not null. So I do need a placeholder value here of some sort to be consistent. 0000. There we go. There. Now I get all three of those values in there. That gives me about values to play with. Because down here what I can do is I can insert into emails, and by hard coding those primary keys, that means that there's no guesswork with respect to the foreign keys. So we're insert into email. Email ID. Here I don't care about the email IDs. I'll just go with address, person ID, values. We'll go ahead and give me one email here, 10, that's the person ID. So my address is chris.burke@unl.edu. Yes, you can randomly email me if you want, if you have nothing better to do with your time. And then my old one, when we were on the CSE system, it's still active, it'll just forward. I'll associate that with myself. And then maybe Joe doesn't have any email because he's a Luddite or something, or he just doesn't like email. We'll go ahead and give Jane here, jdoe@gmail.com, an email here. Right, there we go. And I could put all those in there. Now I can actually do some queries, right? I could select everything from person P, join email E on p.personid is equal to e.personid, and I can see all of those results. Except that I'm not going to be able to see Joe Schmo. Why? I didn't give him any emails. So what could solve that as a review? A right join, or if you want to preserve from the right, so email records would be preserved to the person records. Left join would, if I wanted to reverse person in email, I could do a right join, but I don't read I don't read right to left, so I like this better. Right, there we go. There's that Joe Schmo record with no emails. Right. Excellent. Now let's move on. I mean, 3 records per table, that's probably sufficient. Right? And we've got at least one record to ensure that there's no record in the email table so that we can test our left joins, right? So that's pretty good. Let's come back over here. And by the way, for your project, guess what? you can take that same CSV converter.com, right, and that converted to JSON, that converted to XML. If you go back there, you'll see that it also converts to SQL insert statements. Right? So you don't have to do all that much. If you really wanted to, of course, you could say, like, do something like this, where you start editing things. It has to be with one table. So let's go ahead and select everything from person. There we go. And, okay, well, I don't like typing out all that stuff, so 40, and then, give me somebody else, I don't know.
John Smith.
John, giving me fake names here, man. Smith. All right, and, I don't know, 1999, party like, there we go. Right, and when you do this, you can import and export it, and you can save it as, if you want to, you can go ahead and apply. Yep, there. Before you apply, it'll actually generate SQL code here that you can cut and paste, and then just use that. I'm not going to apply that because I don't want that update. Right? Don't apply. Okay. So the drudgery of typing this stuff out can be, you can save your fingers a little bit of work. All right, come back over here. Now, remember that now that we've designed that part of the database, now we need to support accounts, an annuity account and a savings account. But remember my variation here, we want joint accounts. So first of all, let's think about the account. And to do that, I'm going to go ahead and start with a fresh page. Remember, we've got an account, we've got an annuity account, and a savings account. You could do something like this. Here's account, here's savings, and here's the annuity account. So in other words, 3 tables. That would follow exactly what we did over here in this inheritance hierarchy. That's called a table per class strategy, right? The problem with that is that it produces a lot of tables for not a lot of gain. If you've got a deep inheritance hierarchy, like 2, 3, 4 levels deep, right, that's a lot of tables. Why? Why are you doing so many tables? And when you go to actually pull the data from the database, you're doing join, 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 join all over the place, right? So what we could do instead is not have, I don't, why do I have yellow? Oh, because I was drawing keys before. We'll go ahead and get rid of that 1. Right? In other words, we'll have 2 tables, one for savings accounts and one for annuity accounts. That's called a table per subclass strategy. That's also a perfectly fine strategy, but again, lots of tables for not a lot of payoff. Fewer joins than before, but still many joins. What I'm going to do is I'm going to get rid of all of that, and I'm going to have what's called a single table inheritance hierarchy, or a single table inheritance strategy. I'm going to build this one big table called account, and I'm going to put everything that's relevant to all accounts into this one table. All right, let's take a look at the UML diagram again. There's some things that are in common that will not be allowed to be null, because every account should have them. But there are some things that some accounts have that other accounts do not, and vice versa. Those things will be allowed to be null. Right? How will we tell the difference? This record in this account table is a savings account. How could we do that?
Have a type string?
A type string, S, A, or savings, annuity, whatever you want. That's called a discriminator column. A discriminator column discriminates between these two. It should be called a discernment, because that's a better and more accurate word. But it's a discriminator column that says, no, this is an annuity account, no, this is a savings account. Right? And actually, that's the strategy that I'm going to recommend, especially for your project. Right? Why make many tables when one table do trick? Right? So my first step here is, of course, to create account ID. That's a primary key, integer. That is not the same thing as an account number. Remember over here with the account number, we made that into a string because we wanted to be able to support hyphens, numbers, and letters, or something like that. So immediately you might ask yourself the question, well, wait, why are we doing that as an account ID when we've got this account number? And that's a varchar. Should that be our primary key? Question mark. All right. This gets into what are called natural keys and surrogate keys. Right? Examples of natural keys would be, for people, social security numbers or NUID numbers across the entire NU system. Right? Who's responsible for generating those? The Social Security Office, some goon down at the Canfield that needs to create NUIDs, and there's some automated process or something. All right, so in the history of the United States, or at least the Social Security system, do you think no mistake has ever been made?
No.
In the history of UNL, or the NUIDs at least, do you think that no mistake has ever been made?
Yes. There's never
It's
been a
been-
mistake
it's
that
been
never
perfect?
occurred.
Nope, definitely not. In fact, I think in one of my other sections, there was somebody that was issued 2 NUIDs because they had registered a long time ago, then came back as something like that. And so they were accidentally given 2 NUIDs until they realized the problem, and then they merged those 2 records together. So my enrollment went down from 155 to 154, right, or something like that, right? Those are natural keys. Natural keys are keys that are generated and maintained by something outside of our system, right? If we have no control over those keys, we should not allow those keys to control us, right? Meaning that what if I did use, say, what if I did use an NUID, or here an account number here, as my primary key, and then that permeated throughout my entire database, right? I'm using an account number here, and in that table, and in that table, and in that table, and in that table. Then I get a call saying, we screwed up, sorry. That account number should be 5 instead of 4. I am changing every record in every table in the entirety of my database because I allowed a natural key to control me, right? I'm not going to do that. What I'm going to do is I'm going to do a surrogate key, a key that is generated only for the purposes of my database. So that when somebody calls me up and says, sorry, we're screwed up, that NUID is not unique, you need to change it over here. Okay, great. I change 1 column in 1 table in 1 record, and I'm done, right? But of course I tell them, geez, that's gonna take me hours and hours to do. I really wish you hadn't made that mistake, right? And then, put it on them and make them feel bad, and then take the rest of the day off because, like I said, it's going to take me hours to do this, so I'm going to go home and rest.
You just have to hope they don't manage to somehow screw up your database keys.
Exactly, yeah. What?
The main point of this class is just you telling us that we should be DBAs sometimes.
I don't think that you should be DBAs, but laziness should be your drive, right? That's the drive of humanity, right? Why do we have computers anyway? Right? So why do we build robots? To get rid of manual labor, right? And the utopia someday, 300-400 years in the future, if humanity hasn't wiped itself out, right? Then all we're doing is, artistic endeavors or something like that. And all of our problems are solved, and every little piddly thing is automated somewhere, right? Yes, you're automating somebody out of a job. That's so that we don't have to work, right? Hopefully you can, there will be a transition at some point where, you're being forced to work to pay for food, but at some point the cost of food or the cost of housing or the cost of anything is so minuscule that it should just be free, period, right? That's the eventuality. Now, getting there is going to be a lot of pain. But that is the, what? What'd you say? Yeah, capitalism itself will probably be obsolete. I mean, when basic needs are met for pennies, and distribution can be solved. Oh yeah.
You really was
What? No. Okay. I mean, it's an inevitability. That's the end of technology. The technology is there to be developed so that we don't have to work. Right? Period. Right? We work less. It's a natural progression. Right? And anything else is denying reality. All right. So.
Get back to the database.
Yep. Absolutely. Back to the database here. We're a long way, that's not gonna happen, certainly within my lifetime, probably not within your lifetimes. Right? So anyway, going back to the accounts here, account ID, account number. Let's go over to with our UML diagram here. What else do we need? We need monthly payment, years, balance, and APR. All of those were doubles except for, of course, the years. So years, years. What else was there? Monthly payment, monthly pay. And this is a double. This is an integer. And we do use the keyword double. It's exactly the same as you'd expect. It's a 64-bit IEEE floating point number. So about 17 digits of accuracy. What else? APR and balance. There we go. All doubles. Right. You mentioned, how are we going to determine which type is which? Well, we could look at these columns and say, oh, well, these two are null and these two are there, so clearly it's going to be a savings account. Or vice versa, these aren't there, but these are, therefore it's going to be an annuity account. Right? I'm going to go ahead and take the guesswork out of it and put in type here. Now that can be a single varchar, right? Varchar 1, it's just S or A. But eventually we might have another type of account, a super savings account, right? And so now 2 S's, right? So you might as well just write it out, right? I don't know, 20 or something.
Super savings.
Yep. All right, what else?
Is it
Yeah.
advisable to just have kind of an arbitrary number there? Like 20 isn't intuitive at all. Like, could that potentially, is that like
I mean, when in doubt, 255.
Oh,
Because that's what everybody else does, right? So don't get fancy. Go with the crowd sometimes. Right? No, if there's no, there are other keywords that you can use. What is it? You can use text, which is a placeholder for some large number, I think like 4K. You can say big text, I think, or large text. Large text. There are other keywords that you can use for like 4 megabytes or 4 gigabytes or something. You're reaching the limits of the database though, unless you upgrade to like Postgres or something else. Right? I'll just stick with varchar 255. Right? And there are other implications because if it's so large, it's going to be probably better to store it as a file and then have a reference to that file and load up that file or something. But those are also called blobs. Right? Binary large object.
So,
Yeah.
that probably isn't necessary though, right?
Definitely not for us. No, if you were storing media like an image or something, then you put that into a blob, and it just stores raw bytes.
You probably shouldn't have the dedicated file for storing the first name.
Oh no, not at all. No, definitely not. All right, so I'm going to go ahead and zoom out here, right? And we're going to think about a person as this thing over here, and an account as this thing over here. How do we bring them together so that one person can own many accounts, and many accounts, or one account can be owned by many persons? How are we going to bring those together? How do we do that with? It's a many-to-many relationship. How did we do that with the video game database? Another table sitting right there. Right? You could do it by taking this foreign key and putting it over there, and this foreign key and putting it over there. Without it, this is called a join table. But then you wouldn't be able to model data like this, publish here. Right? Where does it go? Does it go over there? Does it go over there? Both of those are wrong. If you want to model data based on the relationship itself, it needs to be in that join table. And it's not a pure, sometimes we call these things, if I didn't have if I only had these two here, we'd call it a pure join table. But since it has additional data on top of that, we don't call it an impure join table. We just call it a regular join table, right? Yeah.
I have no idea what accent that was.
All right. So I'm going to go ahead and model this as, well, here, let me get rid of all that stuff. with a table in between. What should I call it? A one-to-many relationship here. What should I call this table? Over here, I called it availability. Why? Because that's what it modeled. This game is available on this system or on this platform. Over here, this person blanks this account. This account is blanked by that person.
Account holder?
Owns. Ownership. Why didn't you say owns?
Because you went with like a,
Verb?
whatever kind of word ownership is.
It-
You did that for
Ownership would be a noun, right? We didn't go with the verb owns, right? Everything's going to be a noun. There we go. It's not an interface. An interface is an adverb. Ownable, right? Iterable, right? Able, that's going to be an adverb, right? That's an adverb, right? Okay. You're closer to the SATs than I am.
That was my
Or
lowest
ACTs.
score, I would like to know.
Okay. So, ownership. What are we going to have in here? The very first thing that we have is ownership ID. Right? Just because primary key, primary key, not null, auto increment, that's just the first thing you should do for every table. Right? Then we're going to have two, person ID and account ID. Both of these are going to be foreign keys. This one goes back to this table. This one goes over to this table. And if there were anything else, like say the date that you opened this account, the date that you closed this account or whatever, then that would go into this ownership here. The balance would not go into this ownership, right? Because then the person owns this account with this balance. I guess you could do that in some sense, but that's kind of weird. Right? A balance is an account thing, not an ownership of an account thing. Right? All right. So let's do that now. Before we do that, let's go ahead and go back over here. An account, account ID, account number, et cetera, et cetera. Let's go ahead and jump down here. Create table account. And it is syntax highlighting this for some reason. I was not able to find that account is a keyword, but it's certainly not. I don't know why. Sometimes it'll highlight things that it thinks are keywords in SQL. Don't ask me why. So account ID, int, not null, primary key, auto increment. Generally, the order of those keywords does not matter. I could put in not null after primary key. Just be consistent about it. Account number, which is a varchar. I'll just go ahead and make it 255, not null. Right? And then I'll put in a to-do here. To-do. Make this unique. There we go. Come back to that here in a second. Otherwise, everything else was type, right? And varchar 255. It also thinks that type, and this is not null because we cannot have a dangling type, right? An indeterminate type. And you can put in comments here if you want to, that this should be savings or annuity. In fact, you can change this so that it's not a varchar, it's an enumerated type. There are enums, right? There are, I'm not going to cover them though, right? But if you want to, you can use enums. Right? If you want to, just go ahead and read all about it. Varchar not null type, years, or term years, I think I called it. Term years, int, not, and should I allow this to be null or not? Is that relevant to savings accounts? Nope. So sometimes it can be null when it's an annuity account. If you want to, another alternative here would be to give it a default value for when it's when you've got a savings account, then the default ends up being 0. It's better to use missing data than it is to use a flag value, because how do you know that it's not actually 0? How do you distinguish between those two cases? Right. Term years, what was it? Monthly payment, double. And we do use the keyword double. Right? You can use float. That is a less accurate double. you can use decimal. And then you can provide an arbitrary number of values. That's going to be 10 digits of accuracy with 2 decimals of accuracy. So in other words, that's cash right there, right? I don't like dealing with that kind of stuff. Because when I pull it out and put it into a Java double, it better be a double, right? So there might be something lost in translation there. APR, double, balance, double. There. That looks good so far. Let's go ahead and clear this out and make sure that I did not make any syntax errors and run the entire thing. We're all good. Get rid of that, get rid of that. Now let's create that join table. Create table, oh, I didn't do it up here, but create table if not exists. There you go. And I should be deleting it up above. So every time you add a table, you should probably drop it up here. Drop table if exists, account. There we go. Create table if not exists. What did we call it? Ownership? Ownership. Yeah, let me go over here. And it's ownership ID int primary key not null auto increment. Right. There we go. Person ID, which is going to be a foreign key, int not null. Account ID, int not null. And then I need to make both of those foreign keys. So I'm going to steal the syntax that I put up here. Foreign key person ID. Oops, I didn't copy. Sorry. Copy, paste, paste. There we go. So the foreign key person ID references the person ID in the person table. The account ID references the account in the account table. Why did I not have to remember any of that stuff and how it was spelled and what I named it? Because I followed that consistent naming convention. Right. Bring this all together, all green. Wonderful. At this point, what we can do is we can save this as foo.sql. And then I'm going to show you another trick here. Let's just take a look and see a visualization of our database. For that, I'm going to have to say a new model. Model. No, what is it? Dang it. I should have done this import. There we go. Reverse engineer MySQL script. Select that script that I just made, which was, I called it foo. There we go. And what's that mysterious checkbox there? Place imported objects on a diagram. Execute that. Continue, close. Hey, that looks familiar. Ownership, person, email. Export that, arrange it however you want, export it as a PNG, and guess what? Your design document for a requirement for an ER diagram is done. Right. It all started with a sketch, a series of sketches over here. For your next design document phase, all we're expecting is a nice little sketch like this or a series of sketches, bringing them all together. Right. Cleaned it up a little bit. Right? I was kind of just, mine's really, really drafty. But ultimately, you're going to produce an image that looks like that. Right? Question? No? Okay. So we can go back over here. Let's see. I put in a to-do, right? So let's go back and make that unique. Why would we want to make that unique? Because we don't want two account numbers, 1234A and 1234A, right? We want 1234A and 1234B. So what I'm going to do is I'm going to make this unique. That's it. That's all that's required to make that unique. But often, I am going to be searching along an account number. I'm going to probably be writing queries all day long that say, I want to select out the account number with account number 11042BAC, right? If you're going to be doing that, you should also put on a index, or another way of writing that is just a key. Right? What that will do is that internally, that'll tell the database, look, I want you to maintain an ordering here. It already maintains an ordering with respect to the account ID because it's a primary key, but now it will maintain another ordering internally based on the account number. All those strings will now be sorted internally. The way to think about it is being sorted. Why is that a good thing?
Quick to search.
Quick to search using binary search or some binary search-like thing. It's actually a tree data structure, B trees, but it's the same idea that you cut it in half every single time. Right? Imagine if you didn't have that and you had 1 billion records and you needed to search for that one record. Right? You're going to be doing up to 1 billion comparisons. Right? Versus log of billion, you're going to be doing like 15 comparisons or something. 15, 20 comparisons. Right? Unique, key implies that it's not necessarily unique, but those two things together give us exactly what we want. You've got to spell it right. Unique, there we go. And in case you think that that's, like once you hear that, oh yeah, of course we want to do that. That is not at all common. Let me pull up my comic here. Right. So programming humor is very esoteric, but there are plenty of it because it's the internet's. Right? And so let's go ahead and zoom in on this little comic here. So I think that this is maybe from like 5-10 years ago when MongoDB and NoSQL were the hot thing. Right? So we've got the first person. I think that we've hit MySQL's limits. It's simply too slow. Let's face it. The amount of data is colossal. But his colleague there is questioning him like, what? So I was thinking we should switch to NoSQL. NoSQL is another model. Think maps, where you've got a key value pair mapping. Right? And there's no data integrity though. There's no consistency. There are no rules. Right? You can map anything to anything. Right? Yeah, some of it's fast. Text searching is fast, but everything else, if you've got a financial asset system, you better make sure that you've got data integrity. Right? I've prepared a 3-month battle plan. Framework, refactoring, training workshops, internal tool updates. But he finally realized, wait a second, let me check something. There you go. It's called an index, and it just made your query 20 times faster. Right? And I personally like this because there's no less than 3 times in my career that I've faced this exact same thing. And this is why programming here is esoteric, because until it happens to you, it ain't funny. Right? Once it happens to you, then yeah, I've seen that. I've seen this dude before, right? 3 times so far, exactly. I don't do much production stuff anymore, but the last time it happened, it was files. They were storing files, PDF files for graduate applications, and every time somebody wanted a file, it was taking forever. Why? Because files are blobs. They're large objects. So if you're going to have, you're going to this one, nope, that's not it. The next one, nope, that's not it. Nope, nope, nope. And these are large tables. These are huge tables, right? And it was a fairly large system too. It's going to take a long time. It took like 2 or 3 minutes to just find the file, and then another one, then 3 seconds to load up the file into the browser. And I've seen it all over the place. I've seen data integrity where there's no keys, there's no foreign keys at all, right? I'm like, ugh, nope, not for me. At that point, you're that guy saying, nope, we need to rewrite this entire database. We'll talk about Bobby tables later on. You've probably seen it before, though. Right. Okay. Questions on that? Otherwise, here's my model. There's the final model. I didn't put test data into account. I didn't put test data into ownership. The last thing that I'll show you, I hesitate to show you because it's actually not supported in MySQL, and therefore it's not supported in MariaDB, but MariaDB is, that's what we're using here, MariaDB. It is capable of doing so. Let me show you a find check. Do I have it? Yep, there we go. All right, so remember that depending on the type that we have here, these two might be null, and these two would not be null. We can define a rule that enforces that, right? It's called a check constraint. I'm going to put in a constraint, and I'm going to call it data integrity. Right? I don't know, you need to give it a name. And I'm gonna check to make sure that type is equal to, savings, savings, and if that is, if it is a savings account, then term years is null, and what else? Monthly payment is null, because it's not an annuity, is null, right? And, let me put this down to the next line here so that we see it. The type is going to be equal to an annuity, and APR is not null, and balance, is null, sorry. I'm getting the logic confused here. Balance is null, and term years is not null, and. Basically one big giant rule. I'm going to stop it there because I don't want to type anymore. But you could put in other check constraints. Right? So constraint, valid APR. Yeah, this is maybe not the example that I want to do. Let's do this example instead. Constraint valid APR. The constraint that I'll put in here is a check for making sure that the APR is at least 0 and APR is less than or equal to 1. Remember, I want it on the scale of 0 to 1. So if you put in an APR of -5, that's not a savings account, that's a loan. If you put in an APR of, I guess you could put it, the sky's the limit. Go ahead and put in an APR of 5, like 500% annual.
You should probably call the,
If,
I'm not sure who,
yep, I'm the DBA at the bank. I'll go ahead and put that in. Open up a savings account, go back in and set it to 500 or something, right?
which,
There. Say what?
what, what department investigates
Compliance, probably. Compliance and, yeah, something like that, I'm sure. Anyway, the constraint is you need to give it a name, and here I'm backticking it. I'm just giving it a valid APR. It's a check constraint. It will, anytime data gets put in or anytime data gets updated, it will check this, and if this is false, then it will reject that insert, it will reject that update. That ensures that you can put in actual, rules in your database. Now this will work and this will actually execute. Oops, what's wrong? I'm pretty sure I did it. Constraint, yeah, check. What? You have an error in your, that's how you do it. Uh-oh. Let's take this out and make sure it's not something else. Oh, nope, it is something else. Ownership. I need to go ahead and drop that as well. What order do I do that in? Drop table, if exists, ownership. And because that is referencing the person in the account table, I need to do it in that order. Run this all again. Okay, so my check constraint was, I'm pretty sure that that's how you did it though. Oh, no, check. All right, to do. Right. Or it's constraint, sorry. Constraint, check. That the APR is less than or equal to 1 and APR is greater than or equal to 0. I'm not sure why it's not letting me do this, but whatever. No, it's letting me do it now. I shouldn't have called it to do though. Right. Valid APR. All right, run it all again. All right, Heisenberg.
A table, will that, like, we don't want to lose data, like, quietly, right? Like,
Right.
how would you know that, like, there was, like, a bunch of data points that it didn't load because their APR was wrong?
That's a good question. What you would do is, if you have this chunk of data, so the question for those online was, how do you make sure that you're not losing data? So, for example, you insert 5 records. First one's great, second one's great, third one fails. How do you know that, like, oh, crap, what about this other stuff? But I've already inserted this stuff, so I would need to fix it and then restart it down here. That's a perfect use case for what's called a you got me. ACID principles. A rollback commit. What is it called? Transaction. There we go. Transaction. A transaction where you say, this transaction is an all or nothing thing. I'm going to start my transaction. I'm going to do 1, 2, it fails on 3. Everything gets rolled back like it never happened. Right? Otherwise, 1, 2, 3, it works. Then at the end, it commits, and everything did happen all at once. That's called a transaction. It goes in the ACID principles. The A of ACID principles is atomicity. That means that whatever you define as a transaction, it could be one thing, it could be 5 things, it could be 50 things, right? But you are defining that as a transaction as an all or nothing thing. It's an atomic operation, right? Just like an atom. The original meaning of the word atom meant indivisible, right? Of course, you can divide atoms, right? But they thought of atoms as indivisible thing. Yeah.
You were saying, for an earlier example with constraints, that it wasn't supported by...
Yeah,
MySQL?
no check constraints are supported by MySQL.
Okay,
So it'll allow you to put it in there. It just won't enforce it, unfortunately.
got it.
Upgrade to Postgres, you're good. Change the MariaDB configuration to actively say, I don't care that I'm compatible with MySQL. I do want those features that have been around for 20 plus years, right? And this will be enforced.
Got it. But you don't need us to do constraints on any of our...
I think that there's one that's bonus, and we know that it's not going to be enforced, so we just say, show us what it would look like.
Okay.
For example, here, ownership, I want to make sure that Joe owns account 123. Joe owns account 123. Joe owns account 123, right? That's possible here because of the way that I designed it. As long as it has a different ownership ID for each one of those 3 instances, right? But that's redundant data, right? Of course he owns account 123, right? You can put in a check constraint on the combination of these 2 to ensure that that's going to be, and that actually will be enforced. What is it called? Unique pair. I'm pretty sure I've done it before. Yeah, this check constraint it's not a check constraint, it's just a regular constraint, unique pair, right? And person ID, account ID. There we go. There. I don't know why you're complaining about it. Nope, it's unique. There we go. It's not a check constraint. Check constraints are not enforced, but this will be enforced. So now that Joe owns account 123, there's one record with that combination, and that's it, because the combination of these 2 column values must be unique. That's a constraint. Constraints are supported in every, unless you go like real old, like my ISAM or something like that, which there's SQL, but then there's also drivers underneath, like what's the actual code that is doing all of your database stuff, and I think it's called the driver, but ISM, or like you can strip this down. If you're doing an app, there's a SQLite, which is basically just like a 300K jar that you can throw into your Java project, and you've got a server inside that jar without actually, having a server physical server in the world. But everything works now on CSV files internally, and all the bells and whistles that you have here, you don't have there. More after break. We're way past time. Well, we're not way past time, but we're at time. Right? Have a good spring break, whatever it is.